this unit, we are going to discuss and learn about random variables. The first section is about discrete random variables. Our objectives for this lesson are to calculate, graph, and apply discrete probability distributions, to calculate the expected value or mean, mode, median, variance, standard deviation of a discrete random variable, understand and apply the effect of linear transformations on a single random variable on the mean and variance, understand and apply the effect of linear combinations of n random variables on the mean and variance, and lastly, to understand and apply unbiased estimators of mu and variance. A random variable uses numbers to describe possible outcomes which could result from a random experiment. Often, they're represented by a capital letter such as x, and they can be either discrete or continuous. A discrete random variable has a set of distinct possible values. Some examples of this are the number of goals scored in a soccer game, the number of shirts in a closet. I would like you to take a second and add your own example. The example I'm going to add is the number of students in a class. To determine the value, we can count them. So all of these things that were just listed, the thing that they have in common is that we can count them. So we can count the goals in a soccer game, we can count the number of shirts in the closet, and we can count the number of students in a class. Continuous random variables take on any value within some interval on the number line. So for example, the heights of women, which lie in the interval between 45 and 250 centimeters, the volume of water in a tank, which could lie in the interval from 0 cubic centimeters to 100 cubic centimeters. Take a second and add your own example. The example I'm going to add is the weight of babies. Which could lie in the interval 1 pound to, we'll say, 15 pounds. In order to determine any of these things, what we do is we measure. So to measure the height of women, you would use a tape measure. To measure the volume of water in a tank, we would do some measurements of the calculations, measurements of the dimensions, and then do some calculations. And then for the weights of babies, we would use a scale. So all of these things that are continuous, we measure to get their numbers. And we'll talk about continuous random variables in later sections. So this section today is only on discrete random variables, but I thought it was important to have the conversation about continuous also so we can make the distinction. A probability distribution is the probability that a variable will take a particular value. The probability that the variable x takes the value x, so notice the variable is the capital and the value is the lowercase, is denoted by P of capital X equals lowercase x. If x is a random variable with possible values x1, x2, x3, all the way up to xn, and corresponding probabilities of p1, p2, p3, pn, such that x equals x sub I equals p sub I, where I is 1, 2, 3 up to n, then, okay, pause. What does all of that mean? So x is a random variable. So if we think about our examples, x could be the random variable of the number of goals scored in a soccer game. So the number of possible values, well, we could have 0 goals, 1 goal, 2, 3, 4, 5, all the way up to, more than 10, not likely, but we could keep going, and we don't know how far we could keep going, so that's what that little n means. The probabilities are P1, P2, P3, all the way up to Pn. So P1 corresponds with the probability of x1, which would be 0 goals. P2 corresponds with the probability of x2, which would be 1 goal, and so on and so forth. From there, what we would say is the probability of capital X equals lowercase x. So the probability that the number of goals equals 1 okay? So the probability of the number of goals equals 1 would be, and then that's where that probability comes in. And then I stands for 1, 2, 3, 4, up to n. So that would be like 0 goals, 1 goal, 2 goal, 3 goals. Like 1 is the first instance, not necessarily the value 1. So hopefully that all clears up. If not, make a note. We'll talk about it in class. So with these random variables, we have certain characteristics that always hold. So the first one is that the probability always has to be between 0 and 1. Okay, a probability of 0 means that something will never happen, and a probability of 1 means something will always happen. If we add up all of the probabilities, that's what this stands for, okay? This is sigma, okay? So sigma means add up. So if we add up all of the probabilities, and then I listed that out, P1, P2, P3, all the way up to Pn, if we add them all up, the probability equals 1. Listing out each of the individual probabilities is called the probability distribution. So let's look at an example. You can choose to watch the example along with me and copy it down as I go, or you can choose to pause the video and try the example on your own first, and then resume the video to see how you did. The choice is yours on how you want to proceed here. Example 1. Suppose X is the number of heads obtained when 2 coins are tossed. What are the possible values for X? So the possible values for X, so X could equal 0. You could have 0 heads. X could equal 1. You could have 1 head. Or X could equal 2 because you could have 2 heads. So now we want to know their corresponding probabilities. So the probability of X equaling 1, actually we should probably start with 0. The probability of X equaling, now we already did 0, we'll do 1. And the probability of X equaling 2. Okay, so there's a couple ways to figure this out. So if we think about it, we can make a little table. So I can get a head or a tail from the first coin. From the second coin, I can also get a head or a tail. So I could have 2 heads, a head and a tail and a head, or 2 tails. So looking at this, the probability of 0 heads is 1/4. The probability of 1 head happens twice, so that would be 2/4, which is 1/2. And the probability of 2 heads is 1/4. Is each probability more than 0 and less than 1? Yes. Okay. 0 is less than or equal to 1/2, which is also less than or equal to 1. And 0 is less than or equal to 1/4, which is also less than or equal to 1. And what is the sum of the probabilities? 1/4 plus 2/4 plus 1/4 is 4/4, which equals 1. So because the probability equals 1, which it's supposed to, it means that most likely we're correct. There's still a chance for an error, but this is always a very good check for yourself, is to add up your probability distribution. And if it equals 1, you're most likely correct. We can also display this as a table or a graph. So notice our lowercase x would be the 0, 1, or 2, which is the number of heads we could have. If the value is 1, then our probability is 1/2. If the value is 0, our probability is 1/4, and the same for 2. So we just put it in a table. There's 2 different types of graphs we could use. We could use a bar graph, and 0, that probably is 1/4, so we draw the bar going up to the 4th. 1 is 1/2, 2 is 1/4. Now, this is called a bar graph because there are gaps between the bars. Okay, so bar graphs have gaps. If there's no gap, it's called a histogram. We can also graph it. This is a type of bar graph, but it's a line graph, so we put the points and we draw the lines back down. Okay. So these are all ways we can describe our probabilities as a table or a graph, or as we did up here, we just listed them out. Uniform discrete random variables means that the possible values of a discrete random variable x all have the same probability of occurring. So for example, rolling a die. The outcomes of rolling a die would be 1, 2, 3, 4, 5, 6, and the probability is the same for every one of those things. In contrast, a soccer game, the probability of scoring 0 goals and the probability of scoring 10 goals, while they might both seem unlikely, those probabilities are not the same. And actually, 0 goals is pretty likely. I take that back. But, soccer games, things like that, they're going to change, so those probabilities aren't going to be the same. But rolling a die will be a uniform, discrete variable because those are all the same. Add your own example. I will give you a minute and then I will add mine. My example is very boring. It's flipping a coin. The only two things you can get from a coin are a head or a tail, and the probability of either one should be the same. The expected value, also known as the mean, is the value that can be expected to occur per event. So for a random variable x with possible values x1, x2, x3, xn, and associated probabilities, just the standard definition, the expected value is, once again, EX stands for expected value, so that's E of x, that's our expected value. We have our sigma notation, which means add up. This means that we are multiplying each value by its probability. And then this just shows multiplying each value by its probability and then adding it up. E of x is the mean of the probability distribution of x, and it's sometimes denoted as the Greek letter mu. So you'll notice it's not really a u because there's a tail on both sides, so this is the Greek letter mu. If you are playing a game and the expected value ends up being 0, then that means the game is considered to be fair. And so what that means is you have the same chance of winning and losing, not necessarily the same chance of winning and losing, but you will walk out with nothing most of the time if you play a whole bunch of times. So the probabilities and the earnings balance out with the probabilities of the losses. This is what this formula looks like in the formula booklet, just so you can see the difference. So they just say x of p, and then they have the whole probability thing with the sigma. So this is what it looks like in the formula booklet, and this is up to here is a more drawn out explanation of what that would look like. The mode is the most frequently occurring value of the variable. If we go back to tossing a coin, the highest probability was 1/2, and that happened with one head, so that would be the mode would be 1. The median corresponds to the 50th percentile. So if the possible values are listed in ascending order, the mean value is when the cumulative sum of the probabilities reaches 1/2. So cumulative means add up. So if we think about what we did before with our heads of tossing the two coins, the probability of 0 was 1/4, the probability of 1 was 1/2, and the probability of 2 is also 1/4. If we take these probabilities, they're in ascending order, and if we start adding them up, 1/4, that is not more than 1/2 yet, so the median is not 0. 1/4 plus 1/2 is 3/4. 3/4 is now greater than 1/2, so that means that we have crossed that threshold of 1/2, and so therefore the median would be 1 also. So our mode was 1 because that was the highest probability of 1/2. The median here using the coin toss is also 1. Variance is really just the standard deviation squared. In the calculator, we take the value for sigma. So we talked about sigma before. This is the lowercase sigma. So the lowercase sigma is the standard deviation. We take that from the calculator and then we square it, and that will give us the variance. It's the average of the squares of the distances from the mean. So squares of the distances, so distance from the mean means subtract how far away it is from the mean. Square it means you do that, you subtract, and then you square, and then average means add them all up. It's a measure of the spread of data. And if we want to calculate it by hand, this is the formula that we can look at. However, I think it's easier to think about what we're doing. So we square each value. That's that part right there. Square each value, multiply by its probability, add up those values. So those all get added. And then subtract the square of the expected value. And if we remember from up here, the expected value was multiplying each value by its probability and then adding them up. So you do that, square it, and then subtract it. The standard deviation is also a measure of the spread of the data, and you take the square root of the variance and you use that sigma in the calculator. So Tito's Burritos recorded the number of burritos purchased by its customers in 1 week. 23% purchased 1 burrito, 38% purchased 2 burritos, 21% purchased 3, 13% purchased 4, and 5% purchased 5. State the values of X. So X is 1, 2, 3, 4, 5. Construct a probability table. So we had a probability table up here, so we should refer back to it just to make sure we get the right notation. So our top is the lowercase x, and then it's the probability that big X equals little x. And then our x's are 1, 2, 3, 4, 5. The probability of 1 burrito was 23, so we can use 0.23. 2 was 0.38. 3 was 0.21. 4 was 0.13. And 5 is 0.05. Now we want to graph this. So to graph this, we can do a histogram. Not a histogram, sorry, I take that back. We're going to do a bar graph. We're going to do a bar graph because my bars aren't going to touch. We're going to do a bar graph. So if I look, my lowest is 0.05, so I can go up by, so 0.05, 1/10, 0.15, 0.2, 0.25, 0.3, 0.35, 0.4. And then we had 1, and 1 is 23, so that'll be right about there. 2 is 38, so that one's a little bit higher. I'm going to knock this down a little bit. 3 is 0.21. 4 is 0.13. And 5 was 0.05. And then if we just take a look back at the one that we were given, notice we have to label probability and X. So this is our probability. And this is our X. And it's not a bad idea to give our graph a title. So probability distribution of number, there's a B in number, of burritos purchased. Find the expected value, mode, median, variance, and standard deviation of X. For expected value, I'm just going to take each X and multiply by its probability right underneath it. So it's 1 times 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05, 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. So the expected value is 2.39. Now, someone can't buy 2.39 burritos, but based on the probability, we expect that the average person, like if you had 100 people come in, on average, you would sell 2.39 burritos. So 100 times 2.39, you could expect to sell 239 burritos to those 100 people if the averages work out. The mode, the highest probability is 2. The median, so we start adding up. So 0.23 is not more than a half, so then we'll add 0.38, which is 0.61. Since that is greater than a half, that means that we've hit our threshold, so that means that the median is also 2. Now, for variance, if we look back at the directions for variance, it says that we square each value and multiply it by its probability and then add those up. Okay, so we're going to do that first. So we're going to square each value and multiply it by its probability. So 1 squared, so this is for our, let me see, did I put a notation for variance? Yes, just var x. So for variance of x, 1 squared times 0.23 plus 2 squared times 0.38 plus 3 squared times 0.21 plus 4 squared times 0.13 plus 5 squared times 0.05. So that's the first thing we're going to do. We're going to add up all of those, and that gives me 6.97. So that's the first step. Now, if we look back, the second step is now we subtract the square of the expected value. So from that, I'm going to subtract 2.39 squared. So my variance is 1.26. Now I'm going to round to 1.26 because that is 3 sig figs. Okay, so you should have learned about sig figs last year. Okay, so this is 3 sig figs, 1, 2, 3. Those are our 3 sig figs. Now, I'm going to leave that answer in my calculator though, because for the standard deviation, I have to take the square root of that, and I want to take the square root of the whole thing. So I'm going to take the square root of my answer. So the square root of that, the standard deviation, is 1.12. Okay, so my variance is 1.26. My standard deviation is 1.12. In the context of the problem, explain what the expected value, mode, and median represent. We already talked about what the expected value means. So the expected value means that on average, we can expect people to purchase 2.39 burritos. The expected value, on average, we can expect each customer to purchase 2.39 burritos. So if there are 100 customers, we can expect Tito's to sell 239 burritos. Might need a C in the word can. Okay, the mode is the most frequent. So the most frequent number of burritos purchased was 2. The most frequently purchased number of burritos was 2. And the median, so 50, we can expect 50% of customers to, so the median is what's in the middle. So we can expect 50% of customers to order 2 or less burritos, and then 50% to order 2 or more burritos, because that 2 is right in the middle. So 50% of customers to order up to 2 burritos. Should have just used tacos, it's a shorter word. And 50% to purchase 2 or more burritos. Okay. So this is where we're going to stop for day 1 of notes. We will pick up with the rest of this for day 2. Remember, if you have any questions as you go through this, you can always re-watch the video or make a note, and we can start off class by answering questions we had. If you find any errors, please let me know. I am human. I do make mistakes, so there is a chance I hit a wrong button in the calculator, or I may have switched around my words somewhere without realizing it. So by all means, if you have questions or you think I made a mistake, jot down a note, and we will begin class by going over any questions that you may have on these notes and on this video.